Hello everyone, quick biochemistry basics here. So let's talk about translation in prokaryotes. Translation in prokaryotes is divided into 3 steps: initiation, elongation, and termination. The initiation of translation is carried out by 3 initiation factors: IF1, IF2, and IF3. In the first step of initiation, the initiation factor IF3 binds to the 30th subunit of the ribosome. The binding of IF3 disassociates the 70th ribosome into 30th and 50th subunit. Next, IF1 GTP binds to the A site of the 30th subunit. Binding of IF1 and IF3 to the 30th subunit blocks the A site and the E site of the 30th ribosome. Next, initiation factor IF2 along with charge and formylmethionine tRNA binds to the P site. The structure so formed is known as 30S initiation complex. The binding of IF2 along with N-formylmethionine charged tRNA to the P site causes IF3 to release from the E site. Next, as IF3 is released, 50S subunit along with the mRNA binds to the 30th subunit. Next, GTP associated with IF1 is hydrolyzed to GDP by IF2. As GTP is hydrolyzed, IF1 GDP now releases the A site. Finally, IF2 is also released from the ribosome. This complex so formed is known as 70S initiation complex. Elongation of translation. The elongation of translation is carried out by elongation factors like EFTU, EFTS, and EFG. GTP-bound elongation factor EFTU brings the charged amino acid at the A site of the ribosome. Once the charged amino acid binds, the GTP is hydrolyzed to GDP. Finally, EFTU GDP is released from the ribosome. The elongation factor EFTS helps in the recycling of GDP by GTP. In the next step, there is a peptide bond formation between the 2 amino acids. Next, elongation factor EFG helps in the translocation. The GTP-bound EFG binds to the ribosome and the GTP is hydrolyzed to GDP. As a result of this conformational change, the tRNA carrying 2 amino acids at the A site shifts to the P site of the ribosome. The elongation of translation continues till the stop codons are reached. Once the stop codons reaches the A site, the translational machinery now proceeds for termination. The factors involved in termination are RF1, RF3, and RRF. When stop codons reaches the A site, the termination factor RF1 occupies the A site. The 3 amino acid glycine-glutamine present in RF1 helps in the release of polypeptide chain from the ribosome. This release is triggered when GDP-bound RF3 gets associated with RF1. In the next step, GDP is replaced by GTP, which finally releases RF3. Once the polypeptide chain and RF3 gets disassociated, RRF binds at the A site. In presence of elongation factor EFG, the RRF releases the two uncharged tRNA from E site and the B site. And when finally IF3 binds to the 30th subunit, the translational machinery gets disassociated.